Next attribute that I'm going to talk about is ASPath. ASPath is used mostly to check the best path to the destination. And you can see that I only have two ASs here. This is AS1 and this is AS2. So whatever I receive from the other AS, that is going to have only an AS path of with a length of 1. You can see that. Let me check this on router 1. If I go to router 1, I can see that the AS path has only one value. That's AS path number 2. But if I had multiple ASs in between me and the destination, that would be a little different. Let me show you with an example here. Assuming that this is my AS, I am AS1, I can have, for example, AS2 here, AS3 here, this is AS4, AS5, and this is AS6, for example. And these are the connections that I have. I have connection to AS2 and AS4. AS2 has a connection to AS3. AS4 can have a connection to AS3 and AS5. And of course, these two have connections to AS6. So I have multiple paths to reach to the destinations on AS6. So assuming that I want to reach to AS6, I can go through 1, 2, 3 hops. And I'm going to, I know the meaning of hop right here is a little different from what you are familiar with, because I have not counted the routers, I am counting the ASs here. So this has an AS path of 3, and if I check the destination from this path, I'm going to see this here. I'm going to see 6, 3, 2 as the AS path. I can go through, for example, let me choose red. I can go through AS4, then AS5, and then AS6. So I will see 6, 5, 4 as the AS path. I can even use other ways to reach to the destination. For example, I can go through AS4, then AS3, then AS6, and that would be 6, 4, 6, 3, 4, 6, 3, 4, and even I can even use more complex ways to reach to the destination. For example, I can go through AS2, then to 3, then to 4, then to 5, then to 6, and that would be 6, 5, 4, 3, 2. And now when BGP wants to decide the best path to the destination, it is going to count the number of ASs in between me and the destination. You can see that these have a count of 3 ASs. This one has a count of 5 ASs. So this is not going to be used as the best path to the destination. But these ones are going to be used because they have an AS path of 3. So this is not a good way to choose the best path to the destination, because we do not know anything about the quality of links between ASs. I don't know if the link between AS1 and 2 is a high speed link or a low speed link. If it is a low speed link, that's not going to be a good way to reach the destination, even if even though, of course, this has a lower, AS path number, because the number of ASs in between me and the destination are only 3. But if, for example, other links have a better quality of links and higher speeds, they are better to be used. Even though they have a higher, AS path. So we can manipulate this. And it is very easy to manipulate this. Here in my example, I do not have multiple ASs. I have only one AS, but I can change it by appending by appending a value to the AS path and changing that. Let's go to router 3 and first of all remove the local preference that we had set in previous section. I'm going to remove this, and I'm going to remove this route map as well. So no route map net 50. Now by clearing everything in BGP, if I go to router 1 and check this trace again, this time you can see that router 2 is used as the best path to reach to the destination. I'm going to change it. On router 2, I want to tell the other routers that this is not a good way to use, this is not a good path to use to reach your destination. So let's go to router 2. On router 2, let me clear the screen. I'm going to create a route map, and I'm going to name it AS path prepend and I'm going to match IP address prefix net 50, and I'm going to write it again. For this, I'm going to set AS path, and you can see there is a prepend here, and I'm going to add a value of 2 with a space, another 2 with a space, another 2. I can add any number of AS paths that I want, but this is best to choose the last AS number to be prepended to this route map, because that way you are sure that you are not introducing a loop or a black hole into your BGP logic. So I hit enter. For the rest of the prefixes, I'm not going to make any change. So let me write a prefix list net 50, and I'm going to permit 50 50 50 50 / 32. Now I need to go to router BGP process, and again I'm going to apply this to the route that I am receiving from I2. So let me check the IPBGP summary. I'm going to begin this from neighbor. I have 2 neighbors. This is the one, neighbor 201.22.254. I'm going to assign a route map. The route map is AS path prepend, and I'm going to have it inbound. Now if I clear IPBGP process softly and check my BGP table, now you can see that this has been appended to the beginning of this route. And because this has a very, very higher number of ASs in between the source and the destination, this is not going to be used as a best path. But this one is going to be used as a best path that goes through router 3. And if I go to router 1 and check my IPBGP table, again I can see the same thing. Router 3 is going to be used as the best path for this, but for others, router 2 is best. Now if I try the trace again, you can see that router 3 is being used. So again, AS path prepending is good when you want to change the logic of best path selection for BGP in a safe way. But as I told you, you should use the AS number of your neighboring AS, and you can repeat it as many times as you wish, but it should be the neighboring AS, because you do not want to have a loop or a black hole in your logic.